Okay, this is session number 4, Precalculus. Today is February 2nd, and what we're going to do today, we're going to finish off solving quadratic equations. We have one method to cover, and this is one of the easiest methods. Okay, students feel very comfortable applying this formula. And then we have other types of equations and inequalities. So lots of stuff. I'm going to try to go as slowly as I can, but also as fast as possible because there's a lot stuff to cover. Okay. But if you feel like you're missing something, definitely let me know and stop me. Okay, so let's take a look at the quadratic formula. Some of you probably are familiar with this. Okay, this is a method that you can apply uniformly to any quadratic equation. If everything else fails, you can't figure it out, the factoring, you can't figure it out, square root property, this is the one method that's like that big hammer. You apply it to everything, right? It just works. Okay. There's a way to derive this formula. You do not need to know that. You just need to know how to apply the formula. Okay. So if we have a quadratic equation of the form ax squared plus bx plus c is equal to 0, you have these coefficients attached to your powers of x, then the solution is given by the following: minus b plus or minus square root of this quantity that we're going to call discriminant, square root of b squared minus 4ac, everything divided by 2a. Okay, let's go ahead and just apply it, and then we'll discuss the connection between discriminant and what kind of solutions we can get. All right, and there should be a 0 over here. So our first equation, we have 2x squared plus 5x plus 3. I'm going to denote what my values here are. So a is 2, b is 5, and c is 3. If you want to skip this step, that's fine. That's just me assuming nothing. Okay, I assume that nobody has seen this before. But if you feel comfortable, you can go ahead and feel free to skip this step. Okay, so now I'm just going to apply it. So this would be negative 5 plus or minus square root of the following quantity: 5 squared minus 4 times 2 times 3, divide by 2 times 2. Okay, let's simplify this. This is negative 5 plus or minus what? We get 25 minus 24 under this radical over 4. So this is negative 5 plus or minus square root of 1, which is 1, divide by 4. Okay, and now we find two solutions. Negative 5 minus 1, that's negative 6, and over 4, that's negative 3 over 2. And then negative 5 plus 1, that's negative 4. Divide by 4, that's negative 1. Okay, so here for this problem, we have two answers. And it's typical to label them with indices, right? So let's say x1 is negative 1 and x2 is negative 3 over 2. Doesn't matter how you label them. Okay, either way is fine. Or you can just list them by separating with a comma. All right, so let me stop right here for a moment. Take a look at this solution. Let me know if everything is clear. Okay, see some thumbs up, easy enough. All right, let's go ahead and solve two more problems, and then I'll leave you one for you guys for extra practice. So let's say we have the following: y squared plus y, and I'm going to move that 4 on the other side, so this becomes negative. Again, for the first few problems, I'm going to label my coefficients. A is 1, B is 1, C is negative 4. Okay. So now I'm going to apply this quadratic formula. That's going to be negative 1 plus or minus root. Let's see what we get here. 1 squared minus 4 times 1 times negative 4. So whenever we deal with negatives, we just need to be a little bit careful here. This becomes 2 times 1 on the bottom, right? Okay. So what do we get here? This is negative 1 plus or minus. And under the radical, we get 1 plus 16. Square root of 17, that can be reduced. 17 is a prime number. So this is it. This is what you would have, right? So you could also write it like this. X1 is equal to negative 1 minus root 17 over 2. X2 is equal to negative 1 plus root 17 over 2. And I think on online homework, you have to do this. But if you're just writing it by hand, you can go ahead and leave it as is, plus or minus, save you a little bit of time. Okay. So you can take a look at this and say, oh yeah, this is a perfect example of a quadratic equation where you wouldn't be able to factor it, right? Like these are irrational numbers. These are difficult to kind of eye and figure out what the factorization is. So we would apply quadratic formula to problems where factorization is difficult, not impossible, but challenging. Okay. All right, let's do one more, and then we'll make a connection between discriminant and our solutions. Okay, so this one, we have A is equal to 2, B is negative 8, C is negative 5. Let's go ahead and apply our formula. Minus B, so that's minus minus, right? So negative and negative give us a positive 8, plus or minus b squared. So that's negative 8 squared minus 4 times a, that's 2 times c, that's negative 5 over 2 times 2. Okay, what do we get here? 8, negative 8 squared, that's 64, right? And what do we have? What else do we have? 4 times 5, that's 20. And times 2, that's 40. Okay, so 64 plus 40, what is that? 104 over 4. Okay, let's see, 104. Can we simplify this? 104. How can we factor this? This is 4 times 26, right? We can check this. Let's see, that's 80 plus 24. Yes, so that's the factorization. This one cannot, this is not a perfect square, 26, but 4 is. So we can simplify it a little bit. So this is 8 plus or minus 2 root 26 over 4. Okay, and we can reduce this by 2. That will give us 4 plus or minus root 26 over 2. Okay, so we do want to reduce it, simplify it as much as possible. So that would be your final answer here. Okay, all right, let me project these three together with the formula. The last one, I'm going to let you work on your own. Okay, and you can check with me if you would like, but let's take a pause here. Review these three solutions. Let me know if there's anything you would like to discuss before we move on.
Hello? Hello?
Yes, go. You have a question? Go ahead.
Yeah. Yeah, so you reduce it by 4 over 2, right? Can't you reduce it like 2 over 1? Or
Sure. So if you want to keep going, then 4 over 2, that becomes 2 plus square root of 26 over 2. That's fine.
yeah,
So then if you want to
okay,
split it up, that's okay. But it's not incorrect to leave it in the other form.
okay, gotcha.
Yep,
Thank you.
yep, yep. Any other questions? So we'll try this one. If we have time, we can do this at the end of the class. Okay, but now what I want to do is make this connection with the discriminant. So D stands for discriminant, is this quantity b squared minus 4ac. Okay, That's part of the quadratic equation, part of the quadratic formula, right? So let me highlight it over here. This piece right here, not the radical, but just what's under the radical. Okay, we'll call that discriminant. And just by computing the discriminant, we can come up with a couple of solutions, conclusions. So if your discriminant is greater than zero, strictly greater than zero, right? So positive. Okay, so positive value. You compute it and we get a positive value. What does that mean for your solutions? For your solutions, that means you have two distinct real solutions. Okay, which means on the graph, it will look something like this. Okay, for you have your parabola, maybe it opens downward, right? So that means your graph will be crossing the x-axis at 2 points, and those will be your solutions. Okay, so just by computing this quantity, we can tell how many solutions we have and what kind they are. Real solutions, that means we have intersections, two different points, two different intersections, the x-axis. Okay, now let's see. What if d is equal to 0? Okay, if d is equal to 0, that means you have one real solution, but it's a repeated root. So we're going to talk about multiplicities at some point. Okay, repeated. And the graph will look something like this. Okay, so here's my plane. It's going to touch the x-axis at just 1 point, or maybe open downward, right? So it could be either way, depending on what your parabola is looking like. So that's what one real solution looks like, and it's a repeated root. We'll make that connection with multiplicities and how the graph of that function looks like. Okay, so that's case one, case two. Case three, there's only other option left. What is d is less than 0? Okay, so what if we compute that value and we get negative under the radical? Now, up until today or this semester, we would say there are no solutions in real numbers, and that is correct. However, we know complex numbers now, right? So we've discussed it last time, and we say, yeah, okay, but we know what the complex values are that make this equation true. Okay, so in this case, you would have two distinct complex roots or complex solutions. Okay, so that would be the case. And they're not repeated, they're actually complex conjugates. Do you guys remember what complex conjugates are? What's the definition there? How are they different?
Isn't it the opposite of the sign?
Yeah, of which part, right?
The denominator, right? The bottom number. If we're doing dividing, but it would be of the I, yes.
Yes, okay.
Okay, yeah.
Yeah,
So
you got it. So I know your thought process, right? So you're thinking already how to reduce it. So yes, it's the opposite of the imaginary part, right? Good. Okay, so if you have solution like this, 3 plus 2i, what's your second solution? We can already tell, right? So
Minus
well, I'm asking, what is the conjugate of this?
the
3
negative 2I.
minus 2i.
Yep, 3 minus 2i. So here's your example of two distinct complex solutions, right? What about the graph? What would that look like? No intersections with the x-axis. So something like this, or maybe something like that. Okay. So a couple of problems will ask you to determine the number of solutions and what kind they are. When they say kind, are they real or they complex? Okay, and that is based on this one quantity. All right. Okay, so that's with quadratics. So let's take a brief look of how many different ways we've covered for quadratics. Okay, so factoring, that we can apply if it's easy to determine by just inspecting our function, right? Not always the case. Then square root property. We would apply this method if you have an expression in terms of x squared and then just the number on the other side. Easy enough. We can just take the square root, okay? Square root, I'm sorry, not square root, completing the squared. This method, we learn it here because eventually we're going to need it in other classes, but really you wouldn't necessarily apply this method a lot in pre-calculus. It's good for us to know it because we are going to encounter it. In fact, my Calculus 3 students had to revisit this idea yesterday, okay, when we were doing a couple of problems. So it's interesting to see that connection in pre-calculus, and then boom, 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 3 classes later, we're still doing these operations in these methods, okay? But in general, this method, if you don't have to do it, don't do it. Okay. Then quadratic formula, that's the universal method. You can just apply it to any equation. It's probably the simplest, the most effective way to solve equations. All right. So that's our quadratic equations. Okay. What's on the agenda for today? Other types of equations and then inequalities. So let's go ahead and keep going. Okay, we're gonna go until noon. Then we'll go ahead and take our little break, and then we'll come back and finish as much as we have left. Okay, but I want to make sure that I cover everything before you guys have your homework to do. So other types of equations. The first type we're going to discuss is rational exponents. So if you have a power in your unknown and it's a fraction, how do we deal with that? Let me just give you a reminder of how do we actually deal with fractions in the power. Okay, there's a couple of different ways to rewrite this. Okay, remember that a to the power m over n. One way to think about it is it's 1 over n in the power and then raised to the m, right? So this is going back to the properties of exponents. And we can switch the order of it. We can raise it to the mth power first and then 1 over n. And then this is also equivalent. This is all the same to nth root, right, of this expression. And we can even just take the mth power all the way on the outside. So you do not need to memorize this. We just need to know that this is all the same, right? This is all the same way of writing powers. Okay, and we should be able to go back and forth with the power and the root. Okay, so now knowing this, we can solve these equations, and some of them are pretty straightforward. Okay, we can also check our work. So let's go ahead and solve our rational exponent equations. I have x to the power 5 over 4. That's equal to 32. How am I going to look at it? I'm going to look at it from this point of view. Okay, so this is x to the power 1 over 4 raised to the 5th power. And 32 is 2 raised to the 5th power. Okay. Quantity A raised to the 5th power is equal to quantity B raised to the same power, right? If we can show that we can rewrite these two with the same power, that means what's inside must also be the same. Okay, so that means x to the power 1 over 4 is equal to 2. Now I need to solve for x. I need to get rid of that power of 1 over 4. Okay, one way to think about it is this is 4th root, right? That means if I take everything to the 4th power, I should be able to get rid of that radical on the left. So x is equal to 2 to the 4th. What is that, 16? And that's my answer. Okay, So the goal here was to initially rewrite both parts of the equation raised to the same power, and then what's inside those parentheses has to be the same. Okay. All right, let's go ahead and do the other two, and then we'll pause and have a discussion about these equations. X raised to the power 3 over 2 equal to 125. Okay, so this is x to the power 1/2 is equal to, let me see, can I raise something to the third power and get 125? What do you guys think? 5? Yes. 5 times 5, that's 25. 25 times 5, that's exactly 125. How convenient, right? So this means x to 1 over 2 is equal to 5. That's the same as square root of x is equal to 5. So from here, square each side, we're going to get 25. Okay, good. Okay, last one. Here I have something else inside that parenthesis. That's no problem. We deal with it exactly the same way. Okay, let's see. X plus 5 raised to, let's say, 1/2, and then also raised to the third power. Okay. What about this quantity? What do we raise to the third power to get 8? Anything? 2. Very nice. Okay, so from here, we get x plus 5 raised to 1/2. That's equal to 2. That square root of x plus 5 is equal to 2. We square each side, we're going to get x plus 5 is equal to 4. So minus 5 from each side, -1 is our answer. Okay, so first type of equations that are considered, different type, not quadratic, but also not linear, is the ones with rational exponents. Let's take a pause here, take a look at it. Let me know if there's anything you would like to discuss.
Just real quick. So I'm assuming this is also in the homework as 2.6, right?
Correct.
Okay, because I was like, a lot of formulas I kind of gotta remember how to do. So I'm like, I'll practice those. So that's all I wanted to know. Thank you.
Yeah, yeah. It's good to kind of have like maybe a formula sheet to keep track of everything. So I understand where you're coming from. I have to keep track of everything and kind of have a list of things. So yes, this is also on the homework. Any other questions before we go on? Okay, let's go ahead and do, is there someone raising their hand? Let's take a look. No? Was there somebody with a question? I heard something, but I wasn't sure what that was. Okay, if there's nothing, let's go ahead and do factoring, where our equations are not quadratic. Okay, so factoring higher power polynomials. Okay, and we're not going to go too high. So I'm giving you fourth and third degree polynomial. And the idea is that, let me give you a general form of the polynomial. So it looks of this form right here. We have some coefficients. We usually denote them by a subscript. Okay, that goes with the power of n. Okay, all the way to a1 x plus a null. So this is your general form of the polynomial, and we want to rewrite it as a completely factored form, right? So however many factors we have here. So let's say factor 1, factor 2, and so forth. That's your big idea here. Okay, if you can factor it, that's nice, because then we can apply the zero product rule and solve for our unknowns. Okay, so let's take a look at this equation. The first one, is a fourth degree polynomial, right? So we have x to the fourth. We haven't discussed it, how to solve it yet, but we know how to do it. So by factoring, let's move everything on to one side. So I'm going to do 12x to the fourth minus 3x squared is equal to 0. Okay. I am going to reduce it by 3. So if I divide everything by 3, I'm going to get 4x to the fourth. What's going on with my pen? 4x to the fourth minus, I'm sorry, not, yes, yeah, this is fine. I thought I was dividing it by 4. I'm dividing it by 3. So that's 4x to the fourth minus x squared is equal to 0. Let me make a note here. Do not divide by x. Okay. You might be tempted to remove that x, reduce by x. We can't do that. Remember, we're finding values for x that make this equation true. If you reduce by x, you're going to lose it. You're going to lose some of the solutions. Okay, so that's one of the notes. Kind of keep in mind, if it's unknown, we don't want to divide by it if we have an equation. Okay, so what do we have here? We have a common factor of x squared. So once we pull this out, we're going to get 4x squared minus 1 is equal to 0. Okay? From here, either x squared is equal to 0 or 4x minus 1 is equal to 0. Oh, these are easy to solve. X is equal to 0. Here we get 4x squared is equal to 1. So that's x squared is equal to 1 over 4. So x is equal to plus or minus 1 over 2. Okay, so our solution here is x is equal to 0. That's the solution you would lose if you were to divide by x, and then plus or minus 1/2. Okay, all right, let's solve them all, and then we'll discuss any questions. Next one, I have a cubic expression, right? 4x to the third minus 9x equal to 0. I do not have common factors for the numbers, so the coefficients, I can't cancel anything, that's all right. But I do have a common factor of x. So if I factor out x, I'm going to get 4x squared minus 9 is equal to 0. Okay, so this is again product of two things gives us a 0. That means one of them, or maybe both, are 0. X is equal to 0, or 4x squared minus 9 is equal to 0. From here, this is x squared is equal to 9 over 4. X is equal to plus or minus 3 over 2. Okay, so what are our answers? 0 and plus or minus 3 over 2. Okay, let's see. Last example, I have a third degree polynomial on the left, okay? And this is what we call factoring by grouping. This one is one of those examples that requires a little bit of thinking. So what I'm going to do, I'm going to group these terms like this. You'll see why. X cubed plus x squared is my one group. And then I'm going to factor the negative, and I'm going to get x plus 1 as the second group. Okay, now let's see what happens here. In the first group, I have a common factor of x squared. So once I factor this, I'm going to get x plus 1. Nothing happens for the second group. That's okay, because now x plus 1 is a common factor, right? So now this is our common factor, so we can factor that out. Okay, so if we do x plus 1, factor it, what happens here? This is x squared minus 1. Okay, that's equal to 0. Okay. Let's see. Let me go ahead and finish this all the way, and then Jeremy, I see your hand. I'll answer your question. Okay. X plus 1, x squared minus 1 is also factorable. That's x minus 1 times x plus 1. So now we factored our expression entirely. This is as far as we can go. And from here, we can see that x is equal to either -1 or +1. We have what we would call a repeated root, right? So x plus 1 turns out to be twice. So -1 is a root of multiplicity 2. And that's something that we will discuss once we do a lot more analysis with quadratic. Okay. All right. Let's see. Jeremy, what was your question?
Oh, I was just gonna ask when you first started grouping how
Mhm.
you came to the x plus 1, but I saw that you just factored out that -1 and switched both their signs. So,
Yes. So I factor the negative. Once
mhm,
you take that negative out and put the parentheses around, right? That's equivalent to factoring the negative.
mhm.
Okay. All right. Okay. So let's take a look at these three problems. Review them real quick. You guys let me know if there's anything you would like to discuss in more details. Thomas, go ahead.
Yeah, it's just for the first one, the 12x to the fourth power, that one.
Mhm.
I was just wondering how or why it goes from x squared equals 1/4 to x equals uh, plus or negative 1/2. Like, how does that work?
Okay. So square root of x squared is equal to plus or minus square root of 1 over 4, right? I took the square root of each side. So what is the square root of 1? That's 1. What is the square root of 4? That's 2. So that's where this comes from.
Okay, thank you.
Yep. Yep. Okay. Factoring is done. Let's see what's next. So we've done rational exponent, factoring of expressions that are not quadratic, right? The next type is radical equations. Probably most students' least favorite type in this section, but that's all right. Okay, so radical expressions. I'm gonna give you a couple of forms that you might get. So you might get something like this: one radical is equal to another radical. Okay, or you might get something like this: radical plus a number is equal to another radical. Okay, and there's other different variations. You will see over here that we're going to go through three different examples. The goal is always the same. Goal: eliminate the radical. Okay, that's our goal. How do we eliminate the radical? By squaring, right? So if you have the first form, that's nice because you just square each side, call it a day. Okay, that's the basic methodology. How do we eliminate the radical? By taking the square of each side of the equation. Okay, now it gets a little more complicated as we go on and our problems get more involved. But the basic idea is the same. One note, okay, let me go ahead and make a note in advance. Okay, we might get extraneous solutions. So what we might get these numbers that are introduced in the process of squaring that will work for the squared portion, but not for the original. So we'll learn how to deal with that. So extraneous solutions, and that's why we will always have to check if what we've computed works by plugging it back in. Okay, so let's go ahead and take a look at the first example. This one says the square root of 3x minus 1 minus 2 is equal to 0. Okay, I'm going to put it in the following form: square root on one side, number on the other side. Okay, this is one of the easiest examples because here we just square each side. Okay, so let's go ahead and square each side. So square root of 3x minus 1 squared is equal to 2 squared. From here, we get 3x minus 1 is equal to 4, right? So this is 3x is equal to 5, so x is equal to 5 over 3. Okay, we can check. Let me go ahead and check this. Is that correct? 3 times 5 over 3 minus 1, square root of that, minus 2. What do we get? 3 times 5 over 3, that's 5. 5 minus 1, that's 4. Square root of 4 minus 2. That is 0, right? So that works out. Okay, so our solution here is fine. X is equal to 5 over 3. That works. Okay. All right. Let's go ahead and take a look at the next example. We'll solve all of these and then we'll take a pause and have a discussion. Okay, here I have a radical expression is equal to unknown, right? So the same idea as in the previous example, except now we're squaring x. Okay, so we're going to get square root of 12 minus x squared is equal to x squared. So that's equivalent to 12 minus x is equal to x squared. Let me rewrite it in a standard form. X squared, I'm going to move everything on one side. So this is x squared plus x minus 12 is equal to 0. Okay, let's see. Let's take a look at this. Now that we know how to solve quadratics in many different ways. This one is factorable. Do you guys see what the factorization is? Let's see if we can answer that. What is the factorization of this quadratic?
4 and 3.
So plus 4 negative 3, is that right? X plus 4, x minus 3, yes, very good. Okay, that is the factorization. From here, we have two candidates, negative 4, positive 3. I call them candidates. They might not be solutions. We need to check it. So let's go ahead and check 3. Okay, so 12 minus 3 root of this, is that equal to 3? 12 minus 3 is 9, square root of 3. Square root of 9 is 3, so that works. So this guy is a solution. Okay, let's check the other one. 12 minus negative 4. Is that equal to negative 4? What do you guys think? Is it?
Actually, I don't know. Maybe, yeah, it's 16. So yeah, that's right. Yeah.
But square root of 16 is positive 4, right? Square root of 16
Oh,
is not
look at that.
negative 4. Square root of 16 is positive 4. So this is an extraneous solution. This one does not work. It does work in this form, right? It would work in the squared form, but it doesn't work in the original form. Okay, Because if you take a square root of a positive number, we just get the positive number. Okay, we do not get the negative part. If it's a variable, that's a different story, but we don't get a variable. We get a value under the radical, a number that's positive. Okay, so here's your first example of a number that we get that does not work. It's not going to be correct. So that's the one that you cross over and say, nope, I have one solution. Okay, and the solution is 3. Okay, so let me move this over here. So this is a no, okay, because square root of 16 is positive 4. Okay. All right. So yeah, so problem 1 and 2 done. Let's go ahead and take a look at the next one. This one is a little more involved. We'll have to do a couple of steps here because now I have 2 forms, right? 2 radicals, right? Okay. What the first step is to move one of the radicals on the other side, and it doesn't matter which one. So I'm just gonna write it like this. This is square root of 2x plus 3 is equal to 4 minus square root of x minus 2. Okay, I moved one of the radicals on the other side, and now I'm going to square each side. Now we have to be careful because I have a difference on the right. On the left, that's easy. That's just going to be 2x plus 3. On the right, I need to multiply this through, right? FOIL it, or just apply the formula for the binomial. So 4 squared, that's 16. And then minus double of their product, right? So that would be 8 times x minus 2 plus the square of the other term. So that's going to be x minus 2. Okay, so I applied, if you don't remember, let me give you a quick reminder, a minus b squared, that's a squared minus 2ab plus b squared. I just applied this formula to my expression. Okay, I'm going to move everything that doesn't have a radical on the left. Okay, so what do we get here? What are my common factors? So 2x minus x, that gives me 1x. And then I also have 3 here, 16 and negative 2, right? So 16 minus 2, that's 14. And if I move it to the other side, that's 3 minus 14 should be negative 11. So that's the expression on the left. On the right, I just get negative 8 root x minus 2. Okay, so I get here, I still have that radical, right? Remember the goal. The goal is to eliminate the radical. So sometimes you would have to do it twice. Okay, how did I get 8? That's 2 times a times b, right? Double product of the 2. So 2 times 4 times the radical x minus 2. Okay. All right. So now I still need to get rid of that radical. So now I'm going to square this again. So you can see how it can get a little busy, right? So now I have x minus 11 squared equals to this expression square. Let me go ahead and move over here. Okay, x minus 11 squared, that's x squared minus 22x plus 11 squared, that's 121. Okay, here I get 64, right? That's 8 squared times x minus 2. Okay, what is this? This is a quadratic. We just need to move everything on one side and see what we can do. So x squared is our highest power. Negative 22x minus 64. So I'm going to get negative 86x. And then this is 128. So 121 plus, well, this is negative 128, right? So 121 plus 128, that should give us 249. And that's my equation. Okay. Now at this point, you could do a couple of different things. You could apply the quadratic formula, but this one is actually factorable. And there's no easy way to just see it. You would just have to play around with numbers and see how it factors, but it does factor nicely. X minus 3, x minus 83 is equal to 0. Okay. The product of negative 3 and negative 83 is positive 249. And then the sum is negative 86, right? Okay. So from here, x is equal to 3 or x is equal to 83. These are our candidates. Okay. These are our candidates. So let's go ahead and check if one of them works. I'm going to go ahead and check the 3. Okay, so 2 times 3 plus 3, square root of this, plus 3 minus 2. What is that equal to? 2 times 3 is 6, plus 3, that's 9. Square root of 9 is 3. 3 minus 2 is 1. Square root of that is 1. 3 plus 1, that's 4. That is what we want. X is equal to 3 does work. Okay. Now let's see. What about that x is equal to 83? I can tell already that it's not going to work. Does anyone have an idea why it's not going to work? So take a look at the initial equation and see if you can come up with a critical skill solution of saying why it doesn't work without plugging it in. 83. Seems like a large number, right? Yeah, it's too large. Jeremy, elaborate a little bit. You're right. It's too big, right?
Well, I just took the x minus 2 part and I just
Mm-hmm.
plugged 83 into my head, and you're just going to get 9 from that.
Yes.
And it
Yeah.
can't be negative on the left side either, so it's just going to be
Well,
above
so
4.
that would be square root of, yeah, so that's already 9, right? That's already bigger than 4 because square root of 81 is 9, right? So there you go. You can just see that it's going to be too big. If you're not convinced, you can actually plug in. But this is the extraneous solution. That's not going to work. Okay, so cross it over. Here, one solution, x is equal to positive 3. Okay? All right, so radical equations. Take a look at these 3 problems and let me know if there's anything you would like to discuss before we move on. Okay, if there is nothing to discuss, let's go ahead and take a look at the next set, absolute value equations. Okay, absolute value, let me go ahead and give you a quick reminder of the definition of absolute value function. Okay, so we say that the absolute value of x is equal to just x if it's a number that's greater than or equal to 0, right? Okay, so if you have a value that's 0 or positive, just drop the parentheses, right? Or drop these brackets, okay? And then it's negative or the opposite of it if it's a negative number. So negative of a negative is a positive, okay? So that's your definition of the absolute value. Okay, so from here, we could solve these absolute value equations. And all we have to do is just remember this one right here, this definition. So the absolute value of 3x minus 4 is equal to 8. What does that mean? Okay, so it means the following. It's 3x minus 4 is either equal to 8 or 3x minus 4 is equal to negative 8. Okay, so we kind of split it up in two scenarios. Okay, um, so if that's the case, then we can just simply solve this. These are easy linear equations, right? So 3x is equal to what? Um, 12 for this one, x is equal to 4, or 3x is equal to negative 4, so x is equal to negative 4 over 3. And we can always check this. Let's just go ahead and check real quick. Okay, so is this true? 3 times 4 minus 4, absolute value of this. That's 12 minus 4, that's absolute value of 8, which is 8. Okay, so we checked our first one. What about the second one? 3 times negative 4 over 3 minus 4. What is that? Get rid of this 4. That is absolute value of negative 8. Okay, but that's still 8. So both of these are correct. Okay. Now I'm not saying we should be checking. We're not assuming that okay, we might have extraneous solutions. No, we do not introduce extraneous solutions here. I'm just checking to see that these do indeed work. Okay. All right. So as far as the absolute value equations, that's basically it. We're applying the definition of what an absolute value is. So let's go ahead and solve the rest of these. Okay, what do we get here? Let's move everything that's not with the absolute value on the other side. So we get absolute value of 1 minus 4x is equal to 6. Okay, from here 1 minus 4x is equal to 6, or 1 minus 4x is equal to negative 6. Okay, then these are easy to solve. 6 minus 1, that's 5. X is equal to negative 5 over 4. That's our first scenario. What about here? Negative 4x, negative 6 plus 1. That becomes negative, let me see, minus 1, sorry. That becomes negative 7. Okay, and then x is equal to negative 7 divided by negative 4. That's positive 7 over 4. Okay, so here we have two values that will give us true statements if we plug it back in. I'm not going to check it again, but you can always, if you're not sure, you can just go ahead and plug it in. See what happens. You should get a true statement. Okay, let's do last problem. Okay, what is that we have here? Absolute value of 2x minus 1 is equal to what? Negative 2 plus 7, that's positive 5. So we say 2x minus 1 is equal to 5, or 2x minus 1 is equal to negative 5. Okay, so 2x is equal to 6. From here, x is equal to 3, or 2x is equal to negative 4. So that's x is equal to negative 2. All right. Okay, absolute value equations. Let me pause here for a moment. Take a look at this. Let me know if there are any questions. No problems? No issues? Okay, great. All right, let's see. It's 11:55. Let's go ahead and take our break here. We'll come back by noon. So go ahead and do that now. And let me put it in the chat that we will come back at noon. Come back at noon. We'll see you guys in 5 minutes. Okay, it is noon, right? I see noon on my computer. Let's go ahead and keep going. We still have a whole bunch of stuff to discover. Quadratic forms. So the last part of this section is looking at equations that are not necessarily quadratic as we like to think of them with just powers of 2 and below, but they have a quadratic form. Okay, so this is your first introduction to what we're going to call a substitution method. Okay, substitution. And one way I think about this particular substitution, where you have something that kind of looks like a quadratic, but not quite. So I say A times, and I call this star, this object that's not necessarily just a variable. You'll know exactly what I'm talking about once we look at some problems. Squared plus b times star plus c is equal to 0, right? If I just plug in my x or y for that star, that's a typical quadratic equation. But now let's think in more abstract ways. What if it's an expression? What if it's a whole other expression, not just a variable? We should still be able to solve it. Okay, so let's go ahead and take a look at the first problem. Here I have a fourth degree equation. Okay, I'm going to come up with the following substitution. I'm going to say x squared. I'm going to give it a different name. I'm going to call it t. So I'm relabeling things. So x squared is equal to t. So from here, x to the fourth then is going to be t squared, right? If I just raise each side of my substitution in second power, this is what I get. But now I can rewrite my initial equation as t squared minus 10t plus 9. That is quadratic. That's just our good old quadratic equation that's also factorable. We can easily factor this. This factors as t minus 1 times t minus 9 is equal to 0. So t is equal to 1 or t is equal to 9. That's for our new variable, right? This is our new variable t. Now we go back and substitute it back into our original variable. So if x squared was t, then x is equal to 1. I'm sorry, x squared is equal to 1, and x squared is equal to 9. From here, we get 4 solutions, right? So x is equal to plus or minus 1, and x is equal to plus or minus 3. Okay, fourth degree polynomial, we should get up to 4 solutions. Okay, and we get exactly 4 solutions. So that's how you would approach this problem, where it's not in the quadratic form that we're used to, but it's in a more of a substitution form. Okay, let's take a pause here, take a look at just this example here. Do you guys have any questions? Does this make sense? I see a couple of thumbs up. Okay, let's go ahead and keep going then. Let's see. Let's see. Mikhail is asking, can you go over one last time? Go over what? Could you specify which part? Is there a particular part of the solution that you would like to review? You want the whole problem? Okay, I'm gonna go through the whole problem, I promise, if we have enough time, right? But I can't review the whole. I just don't think it's very time efficient. Okay, but you and I can stay at the end and we'll discuss it. Okay, can we do that? I just want to make sure we cover everything that's on the agenda. Okay, and you might have your answers, your answers if we just keep going with the rest of the problems. All right, let's see. I'm looking at the second example. I have a form that kind of looks like a quadratic, but not quite. So my substitution here will be y minus 1. I'm going to call this t. You can pick any variable you want. So from here, y minus 1 quantity squared is t squared. So I'm going to rewrite my equation as 4t squared minus 9t is equal to negative 2. So that's 4t squared minus 9t is equal to 2. I'm sorry, not equal. It's plus 2 is equal to 0. Okay? How do you guys solve this problem? So I have a quadratic equation. How would you solve it now that you know all these methods? What would be one way to do it? Anyone has a suggestion? Quadratic formula? Jeremy, are you asking or are you telling me?
Well, I mean, you can do it that way. I just don't know if there's a faster, easier way.
Try not to worry about that. What is your way to do it? So I'm not asking for the most efficient way. I'm asking for
Oh,
a way
I would do it
that you
with
are
the
comfortable
quadratic
with.
formula.
Good. Okay, so that's what we're gonna go with. Okay. Somebody might feel more comfortable with factoring, and that's fine. Okay. But yeah, I would like for you to go with the method that you prefer. Okay. Don't worry about what I think. If you solve it, I'm happy. Okay. So let's go with the quadratic formula. Quadratic formula. Okay. So 9 plus or minus square root of what? Negative 9 squared minus 4 times 2 times 4 over 2 times 4. Okay, let's see. What do we get? 9 plus or minus. What's under the radical? That's 81 minus what? 4 times 4 times 2. So that's 81 minus. Okay, so this should be 49, right? Square root of 49 turns out to be a nice number, which is 7. Divide by 8. So 9 plus or minus 7 divide by 8. Okay. 9 plus 7, that's 16. Divide by 8, that's 2. One answer is 2. 9 minus 7, that's 2. Divide by 8, that's 1/4. Okay. Now remember what we solved for. We solved for t. We solved for t. We go back to our original substitution. Y minus 1 is equal to t. So from here, y is equal to t plus 1. So 2 plus 1, that's 3. 1/4 plus 1, what is that? 5 over 4, right? Okay. All right. So here's my substitution. I return to it at some point to find my values for the original variable y. Okay. All right. Let's pause here for a moment. What do you guys think? Any questions? Any feedback? Anything you'd like to discuss? Thumbs up from Haley. Okay. Anyone else?
So the final answer is just 3 and 5/4?
Yes.
Okay.
Yep. It's still a quadratic, right? So one way you could also have done this. Multiply the whole thing through, right? So just multiply y minus 1 squared and negative 9 times y minus 1. Combine like terms, put it all together into the regular quadratic form, and you can still solve it that way. It's a lot longer that way. Okay, and that's why we say, oh, wait a minute, we don't need to do all of that multiplication. This is in a quadratic form. Let's do the substitution, and then you will come up with exactly the same answers. Okay, but yeah, so quadratic equation, two numbers. Okay, two distinct numbers, or one repeated root, or we have complex values, right? Okay, those are the possible solutions for a quadratic equation. Okay, last one of this type. Let's see what my substitution is. X plus 1, let's call it t. Again, you can call it whatever variable you would like. So x plus 1 squared is t squared. I'm going to rewrite my equation as t squared minus 8t minus 9. That's equal to 0. Okay. Is this factorable? What do you guys think?
Yeah,
Okay.
-9 and 1.
Very nice. So t minus 9 plus times t plus 1, that's my factorization. So from here, t is equal to 9 or -1. And we go back to our original substitution, right? X plus 1 is equal to t. So x is equal to t minus 1. So x is 9 minus 1, which is 8, or x is equal to -1 minus 1, which is -2. Okay, so let me list my values here, -2, +8. That's going to be my solution, and you can check it. If you're not sure, if you're not certain, you can always plug it back in and see if that works out. Okay, all right, let's take a look at these three problems. Quadratic form. When do we apply this? When we don't explicitly get that nice ax squared plus bx plus c form, right? So when we need to do a substitution, okay? And there's no way to just say, oh, this is what you do. You just need to recognize it by inspecting your equation and saying, what can I do here, right? And it's okay to just take a pause and say, let me think about it, right? You don't need to immediately know what to do with each equation right away. All right, so, okay, let me stop right here for a moment. You guys have any questions? Let me know. Take a look at this page. We're going to move on to inequalities. No comments? I know it's a lot. I know it's a lot to cover. So that's why I don't expect you to just master it immediately, right? So you're absorbing new information, okay? Let it sink in. You go practice, um, and then you come back and say, okay, I feel like I've mastered this concept, okay? All right, let's see. Let's talk about inequalities, linear inequalities and absolute value inequalities. That's going to be the last part of this entire chapter. So this week we're covering chapter 2. That's going to be the end of it. Okay, before we get into actual solving of inequalities, let's talk a little bit about the notation and what it means as far as graphical representation and algebraic notation. Okay, so whenever we have, now remember, we're working with a real line, right? So here's your line. We say this is a real line. We have a reference point 0, and then here we have negative numbers, and on the right we have positive numbers. Okay, so if we say something like this, x is greater than some value a, what does that mean? Okay, in the interval notation, we would say then from a to infinity. That's the notation that we're going to use. A is not included in our interval. Okay, so graphically, that would mean what? My solutions would be to the right of a, not including a. Okay, and we exclude that point from the graph by putting like a hole in it. Okay, now let's say we go in the opposite way. X is less than a. In the interval notation, we would go from negative infinity to a, parentheses. Okay, on the graph, what would that look like? Here's my real line, here's my a, I'm still excluding it, and that would be everything to the left of that value. Okay, for the inequalities, our solutions will contain a whole bunch of numbers, intervals, right? Infinitely many. So we need to know what's the proper way of referring to those solutions. Okay. Now, what if we have something like this? X is between A and B. The notation for that would be an open interval from A to B, and graphically, okay, let's say A is here and B is here, it would be everything in between those two values. Okay, so I'm highlighting that line segment between A and B, and notice that my endpoints are not included. Now, we could also revisit all of this with what we call non-strict inequalities. So here, let me make a note. This is what we call strict inequalities, meaning we do not allow equality sign here, right? So we do not include the endpoints. So that's the parenthesis, that's that hole in the graph, okay? Non-strict inequalities. All of this would be very similar, except what's going to change? Let's say I am between A and B, allowing A and B being the solution. So less than or equal to, greater than or equal to, right? What is that equal to as far as the notation? This is when we use square brackets. A to B with square brackets. On the real line, we would highlight, or you would shade, right, these points A and B to indicate that the endpoints are also part of the solution. Okay, so for non-strict inequalities, this is what's important. It's less than or equal to or greater than or equal to. We use square brackets. We include the endpoints. And I know it seems insignificant, but it is. Like we need to know when we can include endpoints or not, especially once we start talking about domains and ranges of functions. You will see that some functions are just not defined at endpoints, which means we have to remove them. Okay, otherwise we have discontinuities, we have undefined, we have problematic spots, right? So that's one of the things that you kind of need to keep an eye on as you solve problems. Okay, because if the answer is open parentheses for the interval and you put square brackets, and I'm talking about online homework right now, it will mark it wrong. Okay, so we have to pay attention to what our inequalities look like. Okay, let's go ahead and solve some problems here. Okay, you'll see that as far as the solutions go, we have all the methods now, except the answers will not be just numbers, they will be intervals. So the first set, 4x minus 7 less than or equal to 9. Pretend that this is an equation. Okay, 4x less than or equal to 9 plus 7, right? That's going to be 16. So x is less than or equal to 16 over 4. That's 4. Okay. And now I'm going to make a graphical representation of this solution. Here's my 4. I'm going to shade that point because I have a non-strict inequality, and it's going to the left. X is less than or equal to. So what is my answer? My answer in the interval notation would be from negative infinity. We never include infinity, so square brackets cannot go around positive or negative infinity, up to positive 4 bracket. Okay, let me stop here for a second. Okay, just talking about the notation. Does this make sense? The graph and the interval notation. Is this okay? Yeah? Okay, so now our inequalities can get a little bit more involved. So let's take a look at that one. Part B, 3x plus 2 greater than or equal to 7x minus 1. Again, you can treat it as a linear equation as far as the solving part goes, right? So it's going to be 3x minus 7x on the left greater than or equal to -1 minus 2. Okay, so what happens here? We get 3x minus 7x, that's going to be -4x greater than or equal to -3. Okay, now this one is important. Okay, we're going to make a note here. Okay, if we're going to multiply each side of the inequality by a negative, we have to switch the sign. Okay, so when multiplying inequalities, right? So when we're dealing with equations, no problem. We just multiply by any non-zero, you're good to go. When you're multiplying by negative, okay, change the sign. So flip it the other way around. Okay, so this is equivalent to 4x less than or equal to 3. Okay, I multiply by -1, I have to flip it the other way. So this is then x is less than or equal to 3/4. What's my graph? 3/4 will be shaded. I'm going to the left side of this. And the interval notation for this solution would be -infinity up to 3/4 bracket, right? The inequality is non-strict. We're allowing the endpoint to be part of the solution. Okay. All right. Let me solve the next. Is that just one? Okay. So we'll do this one, and then we'll take a pause and discuss the inequalities. Okay. Now here I have a couple of things to do. I see that I have a negative here. And then I also need to distribute the values, right? So first I'm going to just multiply by -1 and switch the sign, right? So that's going to give me 3, 2x plus 1 less than, I have a strict inequality, 2x plus 4. Okay? Now I'm just going to do the regular operations. So this would be 6x plus 3 less than 4x plus 8. Okay, 6x minus 4x on the left, 8 minus 3 on the right. Okay, that's 2x less than what? 8 minus 3, that's 5. Did I make a mistake? Let me see. Oh, it should be 2x, yes, so that doesn't match my solution here. That's why. So 2x here, 2x here, good catch. So this would be what? Let me see. 4. Okay, 4x, 5 here. Is that right? That looks good, right? Okay.
Yeah, that's not.
Okay. So x is less than 5/4. 5/4. We're not shading this, right? We're leaving it as a hollow dot. So 5/4. We're still going to the left. That's no problem. And then the interval notation for this solution is from -infinity to +5/4, not including parentheses. Okay. All right. Okay, let's stop right here for a moment. Inequalities, solving these inequalities. Do you guys have any questions before we move on to absolute values inequalities? Let's go ahead and discuss it here. Okay, if there are no questions, let's keep going. We're staying on track to cover everything today. Absolute value inequalities. Okay, I'm just gonna dive right into it. Two types that we need to consider. Okay. If you have an inequality of this form, absolute value less than or equal to a number, then your solution will look like an interval like this, from some number to another number. Okay, and you'll see the connection between the graph and the solution. Now, if you have the the inequality going the other way around, let's say some expression, absolute value of that is greater than or equal to a number. Okay, so notice this is important. Less than or equal to, we have this form. Greater than or equal to, you're going to have a solution that will be a union of two intervals. Okay, so from negative infinity to, let's say, a. Now this would be non-strict union. Union, that's U stands for union, b to positive infinity. Okay, so how do we deal with each type? I have two inequalities that go to the left, less than or equal to. Let's go ahead and cover those two. Okay. Not square rooted. Absolute value of 2x plus 3 less than 7. Okay. How do we deal with the inequality of this type? You take your expression that's inside that absolute value and set it up as a compound inequality. That's what we call it. So you can just set it up just like this. Less than, greater than. And what happens here, on the right, we put positive number. On the left, we put negative number. And that is just by the definition of how we define our absolute value. Okay, so that's the general setup. And you might be asking, is that always how it's going to go? The answer is yes. This is the method. Okay, take your expression, put it inside the compound inequality, set it up correctly. Okay, not the other way around. The inequality has to go this way. 7 on the right, negative 7 on the left. And now we solve it. So this is 2x. Subtract 3 from all of them, right? So let me go ahead and do that carefully. Minus 3, minus 3, minus 3. Okay, so we get 2x less than 4 greater than negative 10. Okay, and then divide by 2. That means what? We get negative 5 less than x less than 2. What is this equivalent to? Let's take a look. This is saying x is between negative 5 and positive 2, not including negative 5, positive 2. That's where my solution is. So the interval notation for this is open parentheses negative 5, comma, positive 2. Okay. I'm going to go ahead and do the next one, and then we'll pause for a moment. Okay. Same idea. Now I have absolute value of 2x plus 1 on the outside, less than or equal to 6. Okay, so I have to do one more step here, subtract that 1. So we get less than or equal to 5, right? 6 minus 1. Okay, same setup. I'm going to take my expression here, 2x plus 1. Now, this is non-strict, so I have to make sure that my non-strict inequality stays true. So less than or equal to 5, greater than or equal to negative 5. Okay, minus 1 from each side, all 3, right? This is a compound inequality, so we get 2x less than or equal to what? 4, greater than or equal to negative 6. Okay, so this is x is less than or equal to 2, greater than or equal to negative 3. Let's make a picture that goes with it. Here we are including our endpoints, negative 3 to positive 2, and everything in between. Okay, what is the answer? Bracket, negative 3 to positive 2, also bracket. Okay. All right. Let's pause right here for a moment. Take a look at these two inequalities. Let me know if you would like to discuss any part of these solutions. Okay, nothing, then we'll go ahead and finish this part and then we'll take a quick look on how to solve these graphically. And those are really, really easy to check with Desmos. Okay, so we've done this compound inequality where we have less than or less than or equal to. How do we deal with the inequality where it says greater than or equal to or greater than? Okay, what is the method here? I'm going to use a different color. Okay, the methodology here is slightly different. We're going to set up two parts of the inequality. We would say x plus 9 is greater than or equal to 6, or x plus 9 is less than or equal to negative 6. And this is how we drop the absolute value for the inequalities where the inequality goes the other way around. Okay, so greater than, so we're going the opposite. So you can think about it as, okay, we solve it for less than. What about the other solutions, right? What would those numbers mean? Those numbers would mean that whatever is inside, if we plug in anything from those intervals on the inside, that's going to be greater. So you can think about it as the opposite of what we've gotten in problems A and B. Okay, so x plus 9 is greater than or equal to 6, or x plus 9 is less than or equal to negative 6. Notice I do not put them in one line because it's not going to work. You're going to see that you're going to get this infinite intervals. Okay, so from here, this is x is greater than or equal to what? 6 minus 9, that's negative 3. Over here, that's x is less than or equal to negative 15, right? Okay, so what does that look like? That looks like this, negative 15, somewhere here. I'm going to highlight it. Okay, anything to the left, and then negative 3 over here. Anything to the right of negative 3. What does my solution look like in the interval notation? Negative infinity to negative 15, including this, union, negative 3, positive infinity. That's the algebraic way of rewriting exactly the same thing as I have with the graph, right? Now, you can also make this connection. Okay, what happens if I pick a number from here? Let's just pick a number from here, something like negative 4. Okay, let me ask you this question. If I plug in negative 4, is this a true statement? Negative 4 plus 9, is that absolute value of that, is that greater than or equal to 6? That's a question mark. Is that true? So true or false? This is false, right? This is false. So in a way, think about it. If you pick any number between negative 5 and negative 3, you're going to get a false statement. Okay, that's where we would get less than or equal to, which is how we would solve the inequalities in problems A and B. Okay, now if I pick any other number, let's pick something from here. Let's say I pick 0. That's easy to check. If I pick 0 from here, is this true? 0 plus 9 greater than or equal to 6. Yeah, that's true. 9 is certainly greater than 6. Okay, so one way for you to check if you've done it correctly, pick a random number from your interval, see if that works. Okay, all right, so that's done. Let's go ahead and take a look at the last problem of this type. Okay, and then I'm going to stop right there. We can pick up by graphing next time. That's not essential to your homework. This was more like an FYI. Okay, so what do we do here? Subtract 4 from each side. 10 minus 4. That's greater than 6. I have a strict inequality here, right? Okay. So I set it up this way. X minus 2 is greater than 6, or x minus 2 is less than negative 6. From here, x is greater than 8, or x is less than negative 4. Let's sketch it. Negative 4, we're not including to the left of negative 4 here. Positive 8, also not including. And what is the final answer? In the interval notation, we go from negative infinity to negative 4, parentheses, we're not including it, union, parentheses, 8, positive infinity. Okay? All right. So let's take a look at these problems. You guys let me know if there's any spot where you need me to go over. And then once we discuss it, we will stop the recording. So any questions? This is the good time to answer, to ask them.
I don't think I have any questions. I just think it is a lot to cover, so I guess we'll see how it goes. I don't know.
Yeah. So heads up, that's how we're gonna do the rest of the class. This is a 4 credit class, right? So we will be covering a lot every week. It's not really gonna get any less intense, except right before the exam, you will have 1 week, or the week of the exam, where we don't learn anything new, but we try to maybe catch up, review. But 4 weeks of just straightforward new material, 3, 4 sections a week. So I'm
Okay,
sorry.
no, that's okay,
That's
but
just how the
that
class
helps.
is designed.
That
Yeah,
helps to
yep,
have a week before the exam, so we can just study and relearn what we
sure.
need to do. So yeah,
Yeah,
thank you.
yeah,
You've explained it great. I think I'm understanding. Just again, I have to work through some problems, but it looks
yeah.
good.
And
Thank you.
like I've said in my previous lectures, I think pre-calculus is the most intensive. Like it's a lot. It's a lot to cover, and many colleges have 2 semesters of they split it up in 2 semesters because it's just a lot, right? So we do it 1 semester because I think you guys can handle it. And saves you a little bit of time and a lot of money. So there's definitely a plus to it. But yeah, if you feel like we're covering a lot and we're going at a speed of light, I get that. Is it gonna change? Unlikely. We're just gonna buckle in and strap in and keep doing it the whole semester. But at some point you'll just get used to it. So I guess that's that. All right, let me go ahead and stop the recording right here. And as usual, I will stay online until you need me.